Hello everyone, welcome to the lecture series of blockchain technology. Myself M.Naveenraj, Assistant Professor, Department of CSE IoT. In today's class, we are going to see about the block header and its components. Okay, this session is going to focus on mainly block headers, which are some core structural elements of blockchain responsible for security, integrity, and block linking. So this session is structured to revise what block is, understand block headers and their fields, apply design thinking like empathy, define and ideate, and relate concepts to real world use case and Bitcoin. Okay, so a block is a data structure that contain a list of transactions. A block header is nothing but a metadata. A link to the previous block also it has. Blocks are connected sequentially to form a blockchain. Then what is block header? So here the block header is nothing but a metadata, a section of a block. Okay, the main purpose of block header is uniquely identifies a block, ensures immutability, that maintains security, links block together. Then without a block headers, the Bitcoin blockchain cannot be exist. Okay, so this block header is very important components. A block header contains 6 important fields, that is a version, that is specifies the blockchain rules. Okay, it specifies and it helps nodes understand which protocol version is used. So this is the first field of the block header. Okay, this version. Second thing is a previous block hash. This previous block hash stores the hash of the previous block. It creates a cryptographic link. It ensures the blocks are in correct order. If one block changes, all the next block becomes invalid. So this is the main advantage of second field is previous block hash. Then third one is Merkle root, a single hash representing all transactions in the block generated using a Merkle tree. This Merkle tree is generated using Merkle tree. This helps in fast transaction verifications. Another next field is timestamp. It records date and time of the block creation, when the block has been created and what is the time period of that block. Okay, it helps in difficulty adjustment. Okay, then next field is difficulty target. Defines how hard it to mine a block, controls block generation speed. The next block is nonce. It is a number miner keeps changing. Okay, it is used to find a valid hash that satisfies difficulties. This is the core of proof of work, that is nonce. Slides next is how does it allocate space. A block header size is 80 bytes. Transaction data occupies most of the block. This header remains fixed size. This makes hashing efficient and fast. Next is how is block header responsible for chaining blocks. Each block header stores the previous block's hash. This creates a linked chain. Any modification breaks the chain. This is why the blockchain is a tamper-proof. Next is real life problems. So there is empathy, the lack of trust in centralized system, the security breaches, data manipulations. The user needs secure transaction, integrity focused system and trust without middlemen. User wants a problem is defined as a user wants a secure, integrity oriented transaction system. The main goal is to design a system where data cannot be altered and trust is built through technology, not people. Okay, then ideal is nothing but the transactions are grouped into blocks. Here each block generates a unique hash value. That hash value is stored in the next block. This creates a chain of trust. Any tampering changes the hash detected immediately. Okay, next is I'm going to give an activity. So this discuss why the hash value is critical. Can you tell me why the hash value is critical? Suggest some secure block chaining methods. Okay, the main purpose of this activity is nothing but to improve your conceptual clarity and teamwork. Okay, so this Bitcoin block header is mainly used for proof of work. It's secure block linking. Then it's extremely advantages are mainly extremely secure, tamper-proof design. So the real-world application, the block headers are used in blockchain verification systems, audit trails, supply chain tracking, digital identity systems. So everywhere the data integrity is critical. Okay, so next thing is the checks, it checks the understanding of integrity, then how the Merkle root has been understood by the Merkle tree, then there is no difficulty target we have to place, then nonce. Okay, then visual representation of blockchain address has been helps in terms of easy understanding, then about your various quizzes.